The Urine transport aircraft, also known as the Widowmaker, has 5 gearboxes, and the most complex mechanical transmission mechanism, which not only can quickly fold the entire set of suspends, it can also take off in vertical mode, flipping the rotors 90 degrees in the air, flying at high speed in fixed-wing mode, rolling in the air, etc. The biggest feature of the high-difficulty action Osprey helicopter is that it can be used as a helicopter or fixed one-level flight. Both modes use the same handle to control propeller speed. Helicopter mode. Use it to control vertical lift and landing, and for fixed-wing flight, control acceleration and deceleration. Start by taking off vertically in helicopter mode. Then flip the rotor in the air and turn into fixed-wing flight. The flipping process only requires gently turning the wheel. The complex torque changes inside the flip are controlled by a computer. In the vertical state, the engine's gravity will cause the transmission screw to be squeezed. As the engine compartment flips forward, the airflow will cause the screw squeeze to pull deep, but when the angle is lower, the force of the screw is switched again. The pressure continues to build until it finally locked in. This device cannot use gear transmission because the physical shape of the rod cannot withstand. It cannot withstand such a large torque. Although the compression resistance of the screw thread is not high, it is necessary to separate the inner and outer parts of the two screw sections. The force-bearing area of the outer nest can be infinitely enlarged, and the screws are also eliminated. Don't be afraid of the fatal problem of getting stuck. In a fixed-wing aircraft, the two propellers of the Osprey are ridiculously large. Generally, the propellers of fixed-wing aircraft do not need to be very large. The large transport aircraft SIC-130 is only 4 meters in diameter. The diameter of the helicopter blades needs to be very large. The Osprey's wing size can only be between these two, which is very embarrassing, because according to aerodynamic principles, the actual effective area of the twin propellers is actually very small. The vertical thrust produced is far less than that of a traditional helicopter with a single propeller. Therefore, the lack of lift can only be compensated for by increasing the rotational speed. But this size is too big for fixed-wing flight. The propeller half. The diameter is significantly lower than the bottom of the fuselage, causing the aircraft to land vertically. So any mechanical failure will lead to the destruction of the entire unit. Osprey has 4 times the range of conventional helicopters. The flight speed is twice that of a helicopter, and it completely relies on the high speed of the propeller. In exchange for thrust, all other control surfaces are taken over by the computer. This propeller must have a large angle twisting surface. This is because the speeds inside and outside the propeller are different. The force on the blade will gradually increase from the center. A helicopter hovering at low speed can compensate by simply twisting the blades about 8 degrees. However, the Osprey's horizontal flight requires higher stresses, and the blades must be twisted. Twist to 47 degrees to obtain sufficient support. But this structure will pick up a lot of sand and gravel when in vertical mode. It will cause great damage to the engine. The solution is to open a curve in the air intake. When the air flows through the curve, when the outlet is connected, the clean air can smoothly turn the corner, while the sand and gravel cannot turn due to inertia. In the end, all the bends were intercepted in the guide tube. Ying's engine is a Rolls-Royce turboshaft engine. The two engines are driven by one, connected to the synchronous linkage shaft. Under normal circumstances, it can achieve synchronization and reverse rotation of the two engines. But when one of the engines fails, the clutch automatically disconnects. The linkage is driven by another engine through the transmission shaft at the same time. Easy to run, the Osprey can continue flying at maximum torque with only one engine. For 5 hours, the Osprey's wing sweep angle was exactly the opposite of that of most aircraft. The two sweep angles of the wing tilt forward, not backward. The forward sweep angle is to leave enough space for the propeller. If the wings are in a line, a horizontal straight line, then the engine's center of gravity will be out of balance. The Osprey's wings have the ability to fold and unfold quickly, and each joint, equipped with a gearbox or auxiliary motor, it can turn the entire rotor set within 90 seconds. Complete the folding and reduce the body to 1/3 of the size. The entire suspense system is equipped with a total of 5 gearboxes, and its movements are as precise as. When viewed from the front, the transformer's wings have an upward sweep angle of 3.5 degrees on each side. When the wings are folded parallel to the fuselage, this angle is just right for the two engines too. The aircraft is embedded in the space at the front and rear of the aircraft. To reduce the weight of the Osprey, the entire fuselage is made of lightweight carbon epoxy resin. The resin wing beams and tail are made of 2 harder carbon fiber composite materials. The blade material is made of carbon fiber, and then placed on the blade edge that is prone to impact. Paper wrapped with a piece of titanium alloy and nickel alloy material. Ying is trying to solve the problem of helicopters flying slowly and fixed-wing aircraft being restricted by runways. Problem: It was jointly developed by Boeing and Bell and first launched in 1989. It can carry a total of 13 tons of supplies or 24 soldiers, deployed on aircraft carriers or amphibious assault ships. Apart from the U.S. military, the Japan Ground Self-Defense Force is its only overseas user. It was also called the Widowmaker because of its design flaws that led to frequent accidents.